Oh, right, almost done with lists. It's been a long ride. We're talking about nested lists in this video. So nested lists are just lists inside of other lists. So we can also call them multi-dimensional lists is another way you'll hear them. But remember, any list can contain any sort of elements, whether it's strings or numbers or booleans or other lists. So it might look a bit weird, but it's totally normal. Here we have a list that has 3 elements. If we ran the length of this list, it would give us 3. But each of those elements is its own list. So that's where we get the multi-dimensional part. You might be wondering right about now, when would you ever use something like this? And the answer is actually probably more frequently than you would expect, unless you were expecting frequently, in which case you're right. So here's a couple of examples. If you're building any sort of game, like a board game like tic-tac-toe, or you need to lay things out in a maze, you'll commonly use nested lists. If you're interested in learning about web development, you'll find yourself working with data that contains lists of lists all the time. Like imagine you got some data back from Spotify or iTunes, and it contained 5 most recent playlists for a user. Each one of those playlists would have a list of songs associated with the playlist. So you have a list of playlists. Each playlist is itself a list. And yeah, it might even go further than that because the information for a song inside of a playlist could be another list, or it would most likely be a dictionary, which we haven't talked about yet. But we get these nested structures. Also, if we're talking about any sort of tabular data, any information we would plot on a chart or turn into some sort of visualization, that's almost always nested data as well. So, working with things, any mathematical data structures like matrices, you'll find them nested as well. Basically, anything in data science with Python, your data is almost guaranteed to be nested, oftentimes more than one layer deep. So, just good to know, this is a real thing. It's not just one of those things I'm showing you to be like, hey, look, you can do this in Python, you never will. This is one of those things where it's like, hey, look, you can do this in Python, and you probably will do it all the time. And it's not as scary as it seems if you are feeling intimidated. There's lots of real-world use cases, so let's see just how to access simple data out. So here we have a nested list, 3 items, and each item is another list of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I wanted to access this number here, I first have to access the outer list. So this is the 0th element of the main list. So I access nested list bracket 0, and then I add bracket 1, which will give me 0, 1. Here's another example. We access nested list of 1. So that's going to be this list, 0, 1, 2. So we want 1. And then we use -1 to get the last item. So let's copy this over to my terminal. And let's say I wanted to access 8. How would I do that? Okay, so nested list. And I first need to target this last list, which is 0, 1, 2. Or I could do -1 as well. Oh, what did I do wrong? Nested list. There we go. And -1 gives me the last item. So I could do -1. And then to access 8, I could do 0, 1, or I could do -1, -2 if I wanted to. And I could also, instead of -1 at the beginning, I could do 2 because it's 0, 1, 2. And so the way I would do it typically would be this. I don't like using negative numbers most of the time. I would just do 2, 1. So we just chain them together. So what about printing values or iterating through nested lists? So you have to use 2 loops, which we have seen nested loops before briefly. I let you know they are a thing, and this is a really common use case for them. If you have nested data structures, you can loop through one layer at a time. So in this first example, this first loop is going to go through every item in the top level list. So 3 times it's going to loop through. And this variable right here, 1, is going to be equal to this list the first time through. So then we're going to loop through that list on its own and have its own list, or have its own loop for val in this list, print val. So the first loop is going to go start here on this list, and it's going to run in the second loop 1, 2, 3 times. And then the first loop starts over and moves here, and it runs 1, 2, 3 times, prints them each out, and then it starts over again and does these 3. So this is a very common practice. If you have nested loops, or nested lists, you need to use nested loops to print them out. So here I have a file with a nested list structure representing latitude and longitude coordinates. So each one of these could be a location. Maybe this is maybe we have a clone of Airbnb. And these are the locations of properties that are owned by a user or something. So if we wanted to just loop through them in the simplest way, we could just say for, property, or let's do location, LOC in chords. And if we just print out loc, LOC, don't forget parentheses, and we run this is going to be Python 3, we get our 3 lists. And then instead of that, we could do for chord in location, print chord, which is just going to reference each individual coordinate. In my colon, if we try it now, we end up with what you see here. So using nested loops is definitely a thing with nested lists. However, that also brings us to nested list comprehension. So here's an example. Here we have the same nested list, 3 items that are each sub lists, and they go 1, 2, 3, 4, 5, 6, 7, 8, 9. So just to print the value for each one of these, all we have to do, so inside of array brackets, we have our exact same syntax, but start here. So for 1, or is this an L? I think it's an L. Yeah, that's what it is. For list in nested lists. I mean, that looks exactly like the 1 and the L. I guess they're the same. Well, I wouldn't name a variable 1, so it must be an L. So for list in nested list, so for each one of these, we then have this nested thing, print the value for val in L. Then another example here of using a nested list comprehension is, in this case, to generate a nested list that could represent a game board or something. And we're using range twice. So we could start in either place. We could start here. So we're making this is going to be the individual lists inside the list. We're going to generate a range from 1 to 3. It's not inclusive. So 1 to 3. And for each number in there, we're going to make a list. So we end up with one of these. So if we just ran this, which we've done before, we just get a single list, 1, 2, 3. Okay? But we're doing that multiple times. You can see for each value in the range 1, 2, 3, that means doing it 3 times. We're going to generate this, this, and this. So it's identical, 1, 2, 3, 1, 2, 3, 1, 2, 3. And let's look at it now. There we go. And then here's another example, this time using some lovely nested list comprehension plus conditional logic. Okay, I recorded like a couple of versions of me explaining this last thing. Let me try this again. So this version is very similar to this, except we have some additional conditional logic. So rather than just generating the numbers 1, 2, 3, we're actually taking those numbers and we're deciding if they're even or odd, we're going to spit out an X or an O instead of 1, 2, 3. So let's start with the simple part right here. We're repeating this list generator, this list comprehension that's nested 3 times. So whatever we do, we'll have 3 of them, which is what we end up with. And so what are we actually doing inside that list? Well, we're doing something 3 times again, range 1, 2, 3. And each time through, we're going to call that number num. So num starts at 1. So then we check, is num mod 2 not equal to 0? So that means, is it not even, meaning is it odd? And 1 is, so we do an X. Next time through, in the range, we go from 1 up to 2. So 2, is 2 mod 2 not equal to 0? That's false, because it is even. So we do else 0, or O. And so we get an O. And then range goes up to 3, and that's the last time through. And 3 is odd, so we put an X. And then we repeat this whole thing for the next time through this range. So this range started at 1, now we're at 2. Then we go to 3. And that results in this. So let's take a look at this. And there we go, XOX, XOX, XOX. So this would be like a tic-tac-toe game board, 3 by 3. But let's say we wanted to generate the initial state of a game board, where in our game, our board could start out as like star, 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 or slashes, and then as the game progresses, we fill it in with X or O. So if we just wanted to generate a 3 by 3 grid, a multi-dimensional array of solely asterisks, all we would have to do, we start by repeating something 3 times. So we'll just do star as a string for val in range 1, 4. Or we could shift that. Where'd that go? Oh no, I lost it. Okay, one more time. I must have hit the up arrow. Star for, and we'll just call it I in range 1, 4. So we end up with 3. And what I was trying to say before I lost it was that we could also do something like, 5 to 9, and it doesn't matter. Well, actually, that does matter. It needs to be 5 to 8. Okay, but we can shift this number up. Now, to make it multidimensional, instead of just doing a star, we're going to repeat the same thing. So in here, if we just did this, by the way, we end up with just a single list with star. But to add 3 stars in there, we're going to do star for, we could call it X, it doesn't matter, in range 1, 4. Or we could do 4X in 1, 2, 3 as a list. It does not matter how we structure this. But I think the simplest way is just to use a range. Same thing here. Range 1, 4. And there we go. Oh, gosh. Okay, that was a lot. So congratulations if you made it through here or made it through this. If you just skipped to the end, well, you found a good spot to skip to because it's the end. We made it through. Okay, so next up, we have a couple of exercises. There's one tiny topic I want to cover that will take a minute, and then we're done with lists at least.